Alright, kiddos, welcome back, and here we are. We're going to do some more reaction types today. We just finished synthesis and decomposition, and on this video we're going to do something called single replacement, and I hope to get to double replacement, maybe even more on this video. We'll see how well things go. So single replacement reactions. A reaction in which the atoms of one element replace the atoms of another element in a compound. This is called single replacement. So generically, take a look. If substance A is an element, and we have compound BX, what happens is A can replace B or X, depending upon whether or not it's a metal or a nonmetal. So let's say that A is a metal here. So it will replace B. And so what happens is B is now by itself on the other side, and A is with element X to form compound AX. Yeah, if you could imagine it this way. Let's say there is a young lady, and there's another young lady over here, and let's put her with a young man. Okay, and what happens is there's a replacement, so to speak. So this young lady, let's give her blue here, all right, will be replaced by the young lady with red hair. So we end up with the young lady with blue hair. Whoops, let's make her pink again. The young lady with blue hair is now by herself, right? And the young lady with pink hair is now with the boy. So it's called single replacement. Sort of, kind of got that there? All right. Now, let's try a few examples. It's important to remember that as we do these, metals will replace hydrogen or another metal. Nonmetals will replace nonmetals. So in this particular example, girls have to replace girls, and if there was a boy over here, then boys would have to replace the boys. You'll see as we go through this, hopefully, it will make a bit more sense. So here are a few examples. Copper reacts with silver nitrate. So copper is a metal. It will replace the metal on this side. So you can see that silver is by itself now. And then copper ends up with nitrate. So it turns out to form a copper 2 nitrate. Now this is not balanced, so let's go ahead and balance this. We need 2 nitrates on this side, so I have to put a 2 over here to give me 2 nitrates on the left. That means we have to put a 2 in front of silver, and that reaction is balanced. We'll actually be doing this reaction in class in the lab in the near future. Okay, let's try the next one. Fluorine reacts with sodium bromide. Now fluorine, kiddos, is a nonmetal, so it's going to replace the nonmetal in the compound. So now bromine will be over here by itself, and sodium will be with the nonmetal fluorine. Now that also is not balanced, so this is a great opportunity to practice our balancing. We have 2 bromines here, so if I put a 2 in front of NaBr, it gives me 2 bromines. 2 in front of NaF gives me 2 sodiums and 2 fluorines, and that's what I have on that side as well. Alright, now I want you to try the next one, and when you do this one, I want you to be aware that iron will be a 3+ iron on the other side when it forms a bond. So pause the video and try this example on your own, then come back and we'll see how you did. Alright, welcome back. So iron's a metal, and you replaced copper, the metal on this side, didn't you? So now copper is by itself, and iron is going to be with sulfite. Now remember I told you, or sulfate. Remember I told you that iron was 3+ when it forms a compound on the other side. Sulfate, if you look up that polyatomic ion, is SO4 2 negative. So the compound will be Fe3, sorry, not Fe3, Fe2 to give me 6 positives, parentheses SO4 3 to give me 6 negatives. So now let's take a second to balance this. And we need 2 ions on this side. Looks like we need 3 sulfates, so we'll put a 3 there to give me 3 sulfates and 3 here to give me 3 coppers. Did you get that one right? All right, we'll try the next one. Bromine and magnesium chloride. All right, bromine's a nonmetal, so it's going to replace the nonmetal in the compound. So chlorine will be by itself. Now chlorine's a diatomic element, Cl2, and magnesium will get together with bromine. So magnesium is in group 2, it's 2 positive. Bromine is in group 17, it's 1 negative. So the other compound is MgBr2. And that one's balanced as it's written, so we're done with that. Okay, try the next one. See how well you do on the next one. This one's in words, and you have a homework assignment like this soon. So give the next one a shot, and we'll see how you do. All right, welcome back. Let's see how you did. Aluminum, Al, and silver nitrate. So silver, as you recall, is Ag+. Nitrate is the polyatomic ion, NO3 negative. So we have Ag and O3 as a reactant. Now what's aluminum going to replace? That's right, it's a metal, so it's going to replace the metal here. So now silver is going to be by itself. And aluminum will be with nitrate. And recall, aluminum is 3+. And when it gets together with nitrate, it will form Al parentheses NO3, 3. So that's pretty easily balanced. Let's go ahead and balance it quickly. So I need 3 nitrates, so I'll put a 3 in front of the silver on this side. And to balance the silvers, I'll put a 3 over there. And we're done. Okay, that's called single replacement. All right, the next one is called double replacement. And in this particular situation, we're going to start with 2 compounds and we're going to end with 2 compounds. So if we have compound AX and BY, A replaces B and B replaces A, and so we end up with AY and BX. We call that double replacement. So in this particular example, you can see that calcium and hydrogen switch with each other. So calcium gets together with chlorine to form CaCl2. H gets together with OH, and HOH we commonly call water. So let's try a couple of these examples. I'll do the first couple for you. We'll see if you can do the others. So do you recognize this first example as double replacement? NaOH and CuCl2. So Na is going to replace the Cu, and the Cu is going to replace the Na. So the Na gets together with Cl to form the compound sodium chloride, and copper 2 gets together with the OH to form copper 2 hydroxide. So let's balance this and see how you do with that. We have 2 chlorines on the left side, so I'll put a 2 in front of NaCl. That means we need 2 sodium, so I'll put a 2 in front of NaOH. That gives us 2 hydroxides, which is nice because I need 2 hydroxides over there. So that one's now balanced. Okay, do you recognize the next example, also as double replacement? K replaces the H, and the H replaces the K. So K gets together with the Br to form compound KBr, and H gets together with Cn to form the compound HCN. And that one, fortunately, is balanced as it's written. All right, how about the next one? Why don't you try that one, see how you do, and come back to the video, and we'll see if your answer matches my answer. Okay, welcome back. Did you take silver and replace sodium with it, and then take sodium and replace the silver with it? Yeah. Now let's make sure we get these formulas right. So silver, you folks should know by now, is Ag+, and it's going to get together with Br, and bromine's in group 17, it's 1 negative. So we make AgBr as one of my compounds. And then sodium, remember, gets together with the nitrate. Sodium is Na+. Nitrate's a polyatomic. Look it up. It's NO3 negative. So we end up with NaNO3. And that one's also balanced like it's written. So we were fortunate on those, weren't we? All right, let's do the next one. Let's clear this up so we have a little bit of room here. Okay, calcium acetate reacts with ammonium carbonate. What are we going to make? Well, the calcium is the positive ion. It's going to switch with ammonium, which is the positive ion. And that will, of course, switch out calcium. So calcium is 2+, it's in group 2. It will now be together with carbonate. Carbonate is CO3, 2 negative. So one of my products is simply CaCO3. And then ammonium is the polyatomic NH4+, and it's going to be together with the acetate ion, which is C2H3O2 negative. That's 1 negative. With the ammonium, that's 1 plus. So we make NH4 C2H3O2. Alrighty, let's make sure it's balanced. Let's get rid of some of these other markings here that are in our way right now. So we have 1 calcium and 1 calcium. Good. 1 carbonate and 1 carbonate. Ooh, 1 ammonium and 2 ammoniums. I have to put a 2 in front of that to give me 2 ammoniums. That also gives me 2 acetates, which is nice because that's how many acetates I have. So now that's balanced. Okay, the next one. Lead 2 nitrate and sodium iodide. So let's write this formula out. Lead 2 means it's lead 2+. Nitrate, boy, we sure do see a lot of nitrates, don't we? NO3 negative. So that's going to form Pb parentheses NO3 2. And it's going to react with sodium iodide. Sodium's in group 1, it's 1+. Iodide is in group 17, it's 1 negative. So it's going to react with NaI. Alright, so lead will switch out with sodium, won't it? And so lead will be with the iodide, it looks like. So Pb2+ will be with I negative, so that's Pbi2. And the Na plus will be with the NO3 negative, so that's going to be NaNO3. Positive ion, kiddos, we always write first. Okay, let's balance this. It looks like we have 2 nitrates here, so I have to put a 2 in front of NaNO3 to give me 2 nitrates. Also has 2 sodium, so I'll put a 2 in front of NaI, and that gives me 2 iodines, so that balances also. Alrighty? Okay, one more practice double replacement problem. Let's see how you do with the last one. Pause the video, try it, and then come back to the video and see how you did. Hey, no cheating. I said pause the video and try it yourself. You didn't pause it. Alright, welcome back. So here we go. KOH and H2so4. So K is going to replace the H, which is acting like a metal with a 1+ charge here, and the H will take the place of the K. So let's see what we end up with. K is in group 1, it's 1+, and it's going to get together with SO4. That's the polyatomic ion SO4, 2 negative. So I'm going to make K2SO4. And then H, remember it acts like a metal with a 1+ charge, is going to get together with this OH. OH is the hydroxide ion, OH negative. So we make HOH. Well, we don't like to write it as HOH, we like to write it as H2O. So those would be our products, potassium sulfate and water. Let's balance this one. So let's see what we end up with here. We need 2 potassiums, so I'll put a 2 in front of KOH. That gives us 2 oxygens, plus we have 4 more, there is 6. See, I've only got an oxygen there. Oh, but I have 4 more there, so that's 5. How about if I put a 2 in front of H2O? That'll give me 2 oxygens here. It's these 2 here, plus the 4 I have there is 6. This is 2 plus 4. Okay, that works. That's 6. 2 potassiums on both sides, and a sulfate on both sides. And yeah, that looks like it balances. Let's clean this up so you can see it a bit better. Okay. All right, that's good enough for now. So now we have 4 reaction types. Do you remember what they were? That's right, synthesis, decomposition, single replacement, and double replacement. Alrighty, next time we get together we'll talk about combustion, and then we'll do some other examples. See you soon. Bye-bye.